In previous videos, we talked about exponents and what they represent in terms of numbers and expressions and how we can expand them. And once they're expanded, how we can bring them back and write them with exponents. Today, we're going to look at expressions that have exponents that are being multiplied together. And what is the effect of the exponent on that multiplication problem? So without any further ado, let's get right into it. I'm going to show you a few examples. Okay. I'm going to ask you to take a look at this multiplication problem. It says 2 squared times 2 to the third. Now, before you try to come up with an answer, before you even think of an answer, what I would like you to do is I want you to expand out 2 squared and 2 to the third. So expand those. 2 squared would be 2 times 2 times 2. Let me put parentheses around it. So that would be 2 times 2. 2 to the third would be 2 times 2 times 2 times 2. Well, once that's expanded out, if you were to then ask to write that thing as an expression with an exponent, you could then tell me that that is 2 to the fifth, because there is 1, 2, 3, 4, 5 2's being multiplied by itself. Now, it's no coincidence when you look at the exponents that there's a relationship between the fact that the exponents are 2 and 3 there, and they end up being 5 at the bottom. Now, let's look at a few more and see if you can come up with what you think that connection is. Erase those parentheses from before. Okay, take a look at the following expressions with exponents that I will then extend, and then we'll bring it back and see. Okay, x squared times x to the third. So I want to write those as extended products. So we just looked at one like this with 2 squared and 2 to the third, but let's look at it with the x's. So x squared would be x times x to the third would be x times x times x. And if we bring that all back, that should give us x to the fifth. Okay, so let's look at another example. And after we've looked at a few, I want to try to make a conclusion about what is happening here with the exponents that we get at the beginning and how they end up at the end. You might already be starting to draw your own conclusions. All right, let's look at this one. X squared, y to the third, times x to the fourth. Let's expand it out. So x squared will become x times x. Y to the third will become y times y times y. And then our x to the fourth is x times x times x. Well, let's bring it all back together. It looks like there's 1, 2, 3, 4, 5, 6 x's and still 1, 2, 3 y's. So I think that will become x to the sixth and y to the fourth. Now, maybe you're starting to see it. And if you're starting to think that, hey, when I look at these exponents, the answer that I get at the end seems to be those two things added together, you're absolutely right. So we say, and we have a law for that, if you multiply two exponential expressions together that have the same base, in this example here, x and x, then you keep the base and you add their exponents together. Now, this one uses variables just to show that it could be any number, but you see what's happening here. When the bases are the same, you keep the base. So in this case, again, let's just highlight it. X and x. You keep the base and you add your two exponents together. And if you look at all those ones right above, that's exactly what we did. All right, so now that we know how this works, let's go ahead and practice a couple of them, okay? Okay, take a look at the following. Well, okay, negative 2/3 is the base, and that's to the fourth. But the other base is also negative 2/3, and that one's to the fifth. So it looks like they have the same base. So according to what we just learned, we'll keep the base, negative 2/3. Notice, again, I keep it in parentheses so that the exponent goes to both the numerator and the denominator, and I add that together. 4 plus 5 gives me 9. Okay, let's take a look at another one. 5 to the 94th times 5 to the 78th. Trust me, if you put those numbers into a calculator, you're going to get something that's so big, your calculator is going to give you an error. But we know that we can just keep the base because the base is the same and add our two numbers together. So 5 to the 94 plus 78. Now, maybe you even need a calculator to add those together, but that's going to come out to be 5 to the 172nd. A really big number. All right, let's keep going. We'll do two more. How about this one? Look at all of those different bases. Well, not all of those different ones. There's only two different bases, 6 and 4. So we'll look at 6 to the 5th and 6 to the 14th, and 4 to the 9th and 4 to the 3rd. So just treat each of the bases separately. And you'd end up with 4 to the 9 plus 3. So those come from the exponents of the 4. That's where that came from. And then we have 6 to the 5 plus 14. And those come from the exponents on the 6. So actually, let me finish this off. This will come out to be 4 to the 12th and 6 to the 19th. Okay, there's just one more one that we have to look at. We haven't looked at any that have variables in them yet. So let's look at this last one. Check this out. 2x to the 3rd times 17x to the 7th. Well, I do see that x to the 3rd and x to the 7th have the same base. So I must keep the base and add their exponents together. And you absolutely do. So you end up with x to the 10th. The question is what do you do with the 2 and the 17? Well, you just simply multiply them together. 2 times 17 gives you 34. So this comes out to be 34x to the 10th. And there you have it. That's how you multiply together expressions that have exponents. As long as they have the same base, you're going to keep that base and add the exponents together.